Viewers, today I will be introducing you to the basic statistics. Our course is elementary statistics. So, in our first episode, we're going to be talking about sampling data and experiment. My name is Ajadi Nuruddin. Now, I'm going to start with the basic definition of statistics. Statistics is the study of procedure for collecting, describing, and drawing conclusions from information. And in statistics, we have two things that we need to talk about. The first is the population, and the second is the sample. What is a population? A population includes all individuals under consideration, while a sample is the subset of the population. For example, when we talk about all the students of the University of Louisiana, that is our area of interest, then that's going to be the population. But when I'm talking about students doing elementary statistics, those are the subset from the entire population of students. Okay, that is a sample. Now, we have the parameter and statistic. Anytime I'm talking about parameter, I'm referring to population. And anytime I'm talking about statistic, I'm talking about a sample. So a parameter describes a population characteristic, while a statistic, look at this, does not have S. A statistic describes a sample characteristic. Now, here we talk about method of sampling. When you need to get information from people, there are several ways in which you can get your samples. And the first one is called a simple random sample. This deals with each collection of n population items is equally likely to be selected. In simple random sampling, which is called SRS, this is when your sample is being collected randomly. It does not have a fixed way of getting the information. For example, when you throw a die, okay, you can't predict the outcome of the die. This is randomly done. The outcome is going to be randomly done. Okay. And one good thing about the simple random sampling is that it eliminates bias. So that's one good thing about it. And also, secondly, we have the stratified sampling. In stratified sampling, the entire population is divided into groups, and the groups are called strata before random sampling from each. Now, let me give an example on this. When we talk about stratified sampling, okay, we have all the students offering elementary statistics in the university. We have like 20 sections of students offering elementary statistics, and each of the sections we have nothing less than 35 students. Okay, now all the students offering elementary statistics are called the population, for example. Now each of the sections are going to be the strata. So what we have to do is that get the list of all the students in each section, which are the strata. Then any students selected from each of the sections are going to be what are the sample we needed. Okay, you break down the population into strata, and from each of the strata, you select randomly from each. Stratified sampling looks similar to cluster sampling, but we have some differences. In cluster sampling, the items are drawn from the population in groups or in clusters too. Okay, the items are drawn in groups or in clusters. And lastly, we have the systematic sampling. Systematic sampling, the population items are ordered and samples are taken at regular intervals. In systematic sampling, it's like you going to Walmart and you have a line of people waiting for a bus. Okay, let me put that as an example. You have a line of 100 students waiting on a line for a bus. So in a systematic sampling, you can be like, okay, at every 10th student, those are going to be your sample. So in 100, so you count number 1 to 10, you pick that. That's going to be your first sample. From 11 to 20, you pick that. That's going to be your second sample. So at every 10-10 interval, each sample selected is going to form your sample space. Okay, that's what we call systematic sampling. Now, after we've learned about different ways of selecting samples, then what is data itself? I mean, don't forget the word data is the plural form and the singular form is datum. D-A-T-U-M. So we have two types of data. The first one, we have the qualitative, also called the categorical variables. Okay. And the second one, we have the quantitative, also called the what? The numerical variables. Now, what is the qualitative? In qualitative, from the word qualitative, we have it to be categorical. One, it describes the quality or categories of something. Example, when we talk about gender, gender is categorical. In gender, we have male, we have female. Okay, when we talk about color, we have white, we have black, we have red, we have indigo, so many colors. When we talk about type of car, we have the Mercedes, we have the BMW, we have the Toyota, so many types of cars. So these are categorical variables. So those are the qualitative variables. And then under the subtype, we have the ordinal and the nominal. Okay, the ordinal variables is variables that are in order. For example, when we talk about the grade in class, we have A, B, C, D, E. Okay, so those are what? Those are qualitative. And the easiest way for you to identify the difference between the two is that when we talk about qualitative, it does not involve numerical value. Yes. So they are always categorical. Now, but when we talk about the quantitative variables, this represents measurement or counts. We won't talk about like the height, you're talking about the weight, the number of siblings. If you need information about the weight, you know that that's going to be a numerical variable. The number of siblings, the number of cars, the number of houses, those are numerical variables. And then under the subtype, we have the discrete and continuous. The discrete and the continuous. Now, before I move to the design of experiment, let me explain what is discrete, what is continuous. When we talk about the discrete variable, these are the kind of, the values that can be counted, something that you can count. Discrete, number of cars is countable. Number of houses is countable. The number of shoes is countable. The number of students in this class they are countable. Okay, those are discrete variable. But when we talk about continuous variable, these are measurements. For example, when we talk about the height, when we talk about the weight, these are measurements. Okay, and this involves a measuring tool to take. So that is the difference between the discrete and the continuous. Now we have the design of experiment. Explain what the experimental unit is. Now looking at the picture on the left side, you can see two flowers. One of the flower is dry while the other one looks so radiant. Now, what is the experimental unit? The individuals or subjects being studied in an experiment. Now, looking at this, the flower itself is going to be the experimental unit. And the treatment is going to be the procedures applied to the subject to determine the effect on the outcome. In this case, the treatment is going to be the fertilizers being applied. You can see that the first flower has the application of fertilizer, and the second flower does not have the application of fertilizer. And this is what the design of experiment is, because in the design of experiment, this is a very big topic in statistics. Okay, I'm not going to move deeply into that. Now we have the outcome. The variable being observed or measured in the study is the outcome. What do you observe at the end of the day? That's going to be an outcome. And lastly, we have the randomized experiment. Treatment are assigned to experimental unit at random. This is randomized experiment. And the types of study, the first one we have the randomized experiment as explained, that treatment are assigned randomly, large outcome differences indicate treatment effect. To have a better understanding of this, then we're going to be talking about the analysis of variance, ANOVA, and some other related topics. But the objective of this class is just to let you know the basic definition we're going to be using, in the future of this class. And secondly, we have the observational studies. The investigator observes individual without modifying them. The only job of the investigator is just to observe and make some inferences from the observation, but no modification is going to be done. And lastly, we have the confounding variables, factors that can affect results without being part of the study design. For example, you have a flower and you have a pest affecting the growth of the flower. So this is one of the confounding, although there are some other real life application of it, okay? And the last part of it is going to be the bias in studies. This area is one of the prominent areas in statistics where people spend a lot of time researching on. For a good statistical experiment, one of our objectives is that it must be free from bias. Yes, it must be unbiased. But there are some cases whereby you have some bias in studies. For example, let's have a look at these 4 bias in studies. The first one is called a voluntary response bias. When we talk about a voluntary response bias, results from individuals choosing to participate, often attracting extreme opinions. The voluntary response bias, for example, you have questionnaire, you have some online surveys being done. So this is example of voluntary response bias. An example is you buying something from Amazon, and after like a week, you get a mail asking you to fill in some surveys. So this is voluntary. It's not compulsory for you to fill in the surveys. But the response you're going to provide is going to be based on what you feel like. Now, another instance is this: as a statistics teacher or professor teaching a course, at the end of the semester, you're going to get a survey to assess the class. A student that have an A in this course will probably give a good review, while students that have F will give a bad review. And a student giving a bad review might not truly reflect the competency of the professor, but due to the fact that the student have an F, so he or she is going to feel bad and feel like giving a bad review. The same thing the student that have an A, which will be prompted to give a good review. So this is voluntary response bias. Secondly, we have the self-interest bias. This occurs when study conductors have something to gain from the results, and this is not allowed in statistics because in this case, some of the people that conduct the experiment can manipulate the result to their own taste, and this is a big error in statistics. And the third one is social acceptability bias. This is something that is very common too. Like respondent provides answer they believe are more socially acceptable. In a situation whereby you are asking a respondent, whereby the respondent knows, we have different people with different culture. So there are some culture or some areas whereby women don't do a particular job. Now, when you're asking people in that region, they're going to give you something that they know that is socially acceptable to them. And in the real sense, this can be wrong. So it's going to lead to bias in the study. And the last one is the leading question bias. Questions are phrased to influence responses in a specific direction. This is commonly used by the security operative to get information out from the respondent or from the alleged criminal. So these are all bias in statistics. The key takeaways from this class is that I believe that you are able to understand the sampling method that we have. You will be able to identify the data types, the qualitative, the quantitative, the design effective experiment, and lastly, recognize and how to avoid bias. In our next class, we're going to move to another topic in statistics, and we're going to talk about some basic calculation involving this topic. And the major requirement for this class is going to be the TI-84 calculator or TI-83 calculator. And in my class, I'm going to be showing you how to do it together with the questions too. Thank you very much for watching. Have a good day.